Alright. Okay, I've never been more sick to my stomach because of math before, but I'm doing a little bit of work on trying to figure out the 1 of 1 of 7 of 13 of 110 of 2143 pattern in the periodic table. And nah, that worked better. So before we get to that, I just want to say that what I think the periodic table is, it's two of those merging. That is a 9x9 grid. You're taking a 9x9 grid and a 9x9 grid with a starting point, a reference frame of being here. It's not going to be one of those butted up against itself because of magnetism. Two likes won't attract. This one's going to have to be flipped. So you're going to have one there and one there. This is the 8th dimension, or infinite. Those are going to be touching. Those are going to be the ones side by side for your 88. Your 69, your 69. Now, what I think's happened is that's a solid 9x9 grid, but when you merge two, we're learning how to make a segment. And in learning how to make a segment, we're going to take this map and flip a solid 9x9, but when they join, what I think is going to happen is it's going to come the periodic table. Okay? That is my hypothesis in all this. And the only way I can prove myself wrong or right, well, it's a 9x9, okay? We're going to make it 18 long, which is what the periodic table is, but it's not 9, it's 7. And not only that, there's a bunch of stuff missing from the inside. So we have to account for that. So the nothing matters. So this is the first, okay? What I'm trying to show here is 1 of 1 of 7, because it will define the size of the periodic table. Your 1 over here, when it's in a circle, is no longer an H. And the same thing here. If you bubble something, you have to subtract from what it is. So, the reason I know I'm right is because of the similarities of this step to my reckoner. Hey look, you're starting with the G in the corner. That's your G. Hey look, this one's GD. It's 7 high, but 7 plus 4 is 18 long. So the length of the periodic table, the size of the periodic table, is detrimental of understanding. If that's your element and it's circled, you got to subtract the letter to define the size of the table. 1 of 1 of 7, not 9 anymore. I'm 18. So the next step would be, where's the 13? If that's 1 of 1 of 7 of, where's the next guy? We did this one in this cell. We did this one in this cell. The periodic table, if we're going to reverse engineer it, if this is a 9 and this is a 9, that would have 8 nothings and 8 nothings. Just like the last column is the 8th dimension, and this last column would be the 8th dimension. It's kind of fitting that they're there. And not only the infinites there, we also have a nothing, because, you know, if that's the 9th column, the 8th column would be the 7th dimension of nothing. Okay, so these are other characters. We're not going to get there because we did the first row now. We're looking at an 8, 8. We've learned how to merge the 8th dimension with the 8th dimension to have a merge not of nothing. 1 of 1 of 7 of... Okay, next row. Let's just count 13, and that's where the start of the block would be. And it's a 6 by 6, of course. And if that is a B... Oh, I did the wrong one. I am so sorry. I should put number of page. Anyway, 1 of 1 of 7 of 13 would be boron. Is this boring to you? So we go from that to that to that. To that. Two ways of finding the 13. All right, so now where are we going? What do you got? You have 8 nothings. Okay, 110 is not even a number. 2 to 9 are numbers. You know? 110 plus 91 plus 50 plus 28 plus 13 is 292. 2 to 9 are numbers. 0 and 1 are the building blocks of everything. Or a ring and a 1, let's say. So 110... You have a 1 of 1 of and 110 are not numbers. And 713 and 2143 are numbers. So if they're not numbers, then they're nothing. They're going to be nothing. Now what is nothing? Let's count the nothing, because the white spaces in the periodic table are there for a reason. So you have 8 white spaces, and 8 white spaces, and 7 white spaces. We're talking about the halves of reckoner 1 and reckoner 2. This one is normal, this one is backwards. We probably still need to do upside down and flipped. So we have an 8, an 8, a 7, and a 3 before here of nothing. We're not going to count these, because that's not part of the code yet. That's probably part of the 2143. I didn't get there yet because it's harder to do. So I said to myself, how do you get 110 with these numbers? And I go, okay, 8 times 8, and 8 plus 8, and 7 times 3, plus 7 plus 3. And I was like, ooh. Then I thought about it and I said, it's 111, but you really are counting this. If there's 111 items, you will have 110 spaces between nothings, because these aren't somethings. If these were somethings, but they're nothings, we're looking at the nothings. So I want, maybe that denotes as that, just means you're counting the spaces between cells. And then we get to there. We go from B to BE, just like we went from H to HE. Now, my patterns of observation are pretty much screaming that this is pretty correct, people. With my determination of why the periodic table is built the way the periodic table is built. And these are 5, 6 apart, really, or whatever. Four in between that aren't there, whatever. Oh yeah, there's a space of 4 and 2. Huh. We're going from 8 to 8, 5, and we're going from 2 to 2, 5. $110? 110, anyone? 110, anyone? 110. Yeah, so this tells me that if this is the H, and this is the HE, but this is the B, that tells me that this B is part of this reckoner. You know, like it's like a like if you're gonna stitch two things together, you're gonna have something overlap here from this side to hold it, and this side will have something over here to hold it from here to here. So I think that this and this are part of him, and I think that this and this are part of him. So basically you got helium, hydrogen, oh geez, hydrogen and beryllium, and helium and boron. Anyway, so what do you think of learning how the periodic table was constructed and why? Eh? How about creation code? How about learning about the way that a reckoner works, and in terms of machine items, where you have to name parts to not lose your frame of reference when trying to attain, I don't know, the gift of cellular wireless energy, or maybe like apocalyptic doom for everyone. At this point, I'd choose the latter. Alright, so yeah, I'll just do this. So there's your 1, your 7, your 13, your 110. Only starting the 2143 with a bang, I'd say. But yeah, I just thought of that. You know, I was looking at this going, there's like, you know, 6, 7, 8, and I'm like, okay, woohoo, woohoo. Good way of describing this math. So in conclusion, 1 of 7 means one reckoner, reckoner A, and one reckoner, reckoner B, merging, where one would flip to be backwards, connect infinitely, up and down. So the one reckoner, which is a 9 by 9, and one reckoner, which is a 9 by 9, now becomes a 1 of 7, because now it's only going to be 7 high and 18 long. It retains one element from the beginning, the x-axis, but reduces its y-axis by the 2 reckoners apparently used. Now there are also 2 other dots that are 1 of 15s, and there are some 36 white spaces. 16, 10, and 10. 1, and then the 16, 2, and then the 10, 2, and then the 10. And the next bit starts at 13th position. Is it me? Or does this really follow the pattern? In the last paper that we did together, I wrote that. An 8 is a circled 7. It's on a paper. That's a 1. The 8 is a circled 7. That's your 1 of 7. The 85 is a 13. The 85 and the 25 is 110. I have a 2 that I haven't touched to start 2143. Now I see the circled 7 being the 1, so 2, 1. The 4 digits 2, 5, and 8, 5 as a 1, or as a 13. What is it? I don't know. I thought I was going to do it. 21. There's 4 things. And it adds up to 20. Yeah, 20. Yeah, a 2. There's a 25 and an 85. 25 and an 85, so a 2, 5, 5, 8 would just be a 20 added individually. And if 0 is a 1, that could be your 3. For your... God damn it, I'll just show you with my finger. For your 21, 1, 2, 3, 4. When you sum them, it's 20. And if 0 is a 1. If 0 is a 1. Okay, the whole concept of this, it should not... Like, even if you're a coder, the concept of doing 6 operations but leaving the 7th for a return function or something like that, like a feedback loop. I'm trying to create a feedback loop on a bunch of magnetic flywheels to hopefully create equilibrium of balance, and slow and steady wins the rate, the energy in. Who knows, one day you could get off the bike and the feedback will support an equilibrium. Who knows what speed it has to turn at? 88 miles per hour? Is it the 88 miles per hour of the two reckoners of the 8th dimension infinite going together? Could it be? How could they know?